Ever looked up at the night sky and seen that tiny red dot? That's Mars. And for decades, we've dreamed of calling it our second home. But what would it actually take to live on the red planet? It's a question that's more science than fiction these days, so grab your space helmets because we're about to take a deep dive into the incredible challenges and amazing possibilities of colonizing Mars. First things first, getting there. The journey to Mars is no weekend road trip. It takes about 7 to 9 months, crammed into a tiny spacecraft, traveling millions of miles through the vacuum of space. Astronauts would be exposed to cosmic radiation, which is way more intense than anything we experience on Earth, protected by our magnetic field. This radiation can damage DNA and increase the risk of cancer. And let's not forget the psychological toll. Being cooped up with a few other people for that long with no escape is a huge mental challenge. Mission simulations on Earth, like the HIC's project, have shown that crew morale and cohesion are absolutely critical for success. Okay, let's say we've survived the trip. Touchdown on Mars. We've landed. Now what? The first thing we'd notice is the air, or rather, the lack of it. The Martian atmosphere is incredibly thin, about 1% the density of Earth's, and it's 95% carbon dioxide. You can't breathe it. Step outside without a suit, and the low pressure would literally cause your blood to boil. So rule number 1 of living on Mars, always wear your suit. And these aren't just fashion statements. They are personal mobile life support systems, protecting you from the deadly atmosphere and extreme temperatures. Speaking of temperature, Mars is cold, like really cold. The average temperature is about minus 80 degrees Fahrenheit, or minus 62 degrees Celsius. It can swing wildly, from a relatively balmy 70 degrees Fahrenheit at the equator in summer to a bone-chilling minus 200 degrees Fahrenheit at the poles in winter. So our habitats would need to be incredibly well insulated and have a robust power source to keep us warm. Where does that power come from? Solar panels are a good option, especially near the equator, but Mars gets less sunlight than Earth and is famous for its planet-engulfing dust storms that can last for weeks, blocking out the sun and rendering solar panels useless. That's why nuclear power, specifically radioisotope thermoelectric generators or RTGs, is a leading contender. They provide a steady, reliable source of power day and night, storm or shine. Now that we're warm and can breathe inside our habitat, we're going to get hungry. We can't just keep shipping food from Earth forever. It's ridiculously expensive and impractical. We need to grow our own food. Remember Matt Damon in The Martian? He had the right idea. But Martian soil, or regolith, is not exactly farm-friendly. It lacks the organic nutrients that plants need and contains toxic compounds called perchlorates. So we'd have to process the soil, wash out the harmful stuff, and fertilize it, probably using astronaut waste, just like in the movie. Early Martian farmers would likely start with hydroponics or aeroponics inside pressurized greenhouses, carefully controlling the light, water, and nutrients to grow crops like lettuce, tomatoes, and potatoes. This isn't just about food. It's about creating a self-sustaining ecosystem. And what about water? We can't survive without it. Luckily, Mars has water, but it's frozen. There are vast ice caps at the poles and evidence of subsurface ice deposits across the planet. The challenge is getting to it and melting it. Future missions will likely involve robotic miners drilling into the ground, extracting the ice, and then heating it in a contained system to produce liquid water. This water would be for drinking, watering plants, and also for creating more breathable air. Through a process called electrolysis, we can split water molecules, H2O, into hydrogen and oxygen. The oxygen is for breathing, and the hydrogen can be combined with carbon dioxide from the atmosphere to create methane, which is a rocket fuel. This is called in situ resource utilization, or ISRU, and it's the key to making a Mars colony truly independent. We could literally make our own rocket fuel to get back to Earth. How cool is that? But living on Mars isn't just about overcoming the physical environment, it's also about building a society. How would we govern ourselves? What laws would apply? The Outer Space Treaty of 1967 says that no nation can claim sovereignty over celestial bodies, but it doesn't lay out a plan for a civil society on another planet. The first Martians would be pioneers in every sense of the word, not just technologically, but socially and politically. They would have to create a new framework for living together, millions of miles from any established government. And then there's the gravity. Mars has only about 38% of Earth's gravity. While it might be fun to jump around and feel super strong at first, long-term exposure to low gravity has serious health consequences. Our bodies are adapted to Earth's pull. Without it, our muscles atrophy and our bones lose density, similar to what happens to astronauts on the International Space Station, but potentially much worse over a lifetime. Would children born on Mars even be able to visit Earth, where their bodies would suddenly feel 3 times heavier? These are profound questions we don't have answers to yet. Scientists are exploring solutions like creating artificial gravity using large, spinning centrifuges within habitats, but that adds another layer of complexity and cost. Even with all these hurdles, the pull of Mars is undeniable. It represents the next great leap for humankind, a chance to become a multiplanetary species. Doing so would be a kind of insurance policy for humanity, protecting us from a catastrophe that could wipe out life on Earth. But more than that, it speaks to our innate drive to explore, to push boundaries, and to see what lies over the next horizon. The first person to walk on Mars is likely alive today. The challenges are immense, from radiation and dust storms to growing food and creating a new society. It will require the best of our technology, our ingenuity, and our collaborative spirit. But imagine it. Imagine watching a blue sunset from the surface of another world, knowing you're part of the first generation of Martians. It's a breathtaking vision of the future, and one that we are slowly but surely working to make a reality. Thanks for joining me on this journey to the Red Planet. What do you think is the biggest challenge to overcome? Let me know in the comments below. And if you enjoyed this cosmic adventure, don't forget to like this video and subscribe for more explorations into the future of science and space. See you next time.